For general mathematics, we have this lesson on piecewise definition of function. Now we read. A piecewise definition of functions defines two or more equations which have distinct restrictions or conditions. Below is an example of a piecewise defined function. Now it includes three equations. First, y is equal to 4 with a condition that x is less than 7. For the second equation, we have y is equal to x minus 3. And the condition is if x is greater than or equal to 4 and x is less than or equal to 7. For equation number 3, we have y is equal to 5 minus x with a condition or restriction that x is greater than 4. Now, to be able to illustrate the graph, to be able to illustrate the piecewise defined function, let us graph the three involved equations. Okay, first, we have y is equal to 4. So, we graph y is equal to 4. And this is a line, no? Yeah. And then, now, when we graph the three equations, we use a pencil or a ball pen with a finer tip, no? Because we don't because later on we will only show the graph that corresponds to the interval given by the condition. We really do not need to show the totality of the graph of the three equations. And then we mark it as this is y is equal to 4. Okay. For the second equation, y is equal to x minus 3. Okay, now we construct the table of values. Okay. When x is 0, y is equal to negative 3. When y is 0, y is equal to positive 3. So, we plot these points. Okay, when x is 0, y is equal to negative 3. So, here it is. And then when y is 0, x is equal to 3. And then we draw the line corresponding to this, to the table of values. Okay, or we draw the line of this linear equation. And then we mark. Now this is the line for y is equal to x minus 3. Now for the third equation, we have y is equal to 5 minus x. Now constructing the table of values, okay, we have when y is 0, x is equal to positive 5. When x is 0, y is equal to, again, positive 5. Okay. So where is that? When x is 0, y is 5. And then when y is 0, when x is 0, when y is 0, x is equal to 5. So we construct the line for this equation. And then we mark this is the line for y is equal to 5 minus x. Now, we mark or we draw the graph corresponding to the interval or condition. Now, for the first line, we have this restriction that x is less than 7. So from here, this is x is equal to 7. We are going to draw the graph corresponding to that condition or to that interval. Yeah. So when graphing, when, when graphing the condition, we need to use a marker with a thicker tip or a bigger tip, to make it more to make it more distinct. No, it's because as I have said, we do not need to show the graph of the three linear equations. What we only need to show is the graph of the piecewise defined function, and we need to locate the interval. Okay, for the second equation, we have x minus 3. And we have this condition or interval that x should be less than or equal to 7. And where is 7? Here. And x should be greater than or equal to 4. And where is 4? It is here. So we draw a thicker line for this. So there it is. And for the third equation, we have y is equal to 5 minus x. And we have this condition that x should be greater than 4. And where is 4? So we only draw the line corresponding to this condition. Okay? Yeah, so there it is. So this is the graph of the piecewise defined function.